Imagine looking up at the night sky and realizing the North Star, Polaris, is missing. Today, September 24, 2025, astronomers report that Polaris has exploded. This isn't just another star fading away, it's the end of a cosmic icon that's guided humanity for centuries. Observatories worldwide detected a sudden, violent burst of energy from Ursa Minor, confirming the unthinkable. Polaris is gone. Scientists scrambled to verify the data, but the evidence was overwhelming, a supernova, witnessed in real time. Polaris isn't just a star, it's a symbol woven into our history and culture, a beacon for travelers and dreamers alike. Its loss is both a scientific mystery and a deeply personal moment for humanity. The world is watching, full of questions. What does this mean for us? Are we in danger? What happens now that the North Star is no more? The investigation begins, and we're all students of the cosmos, waiting to learn from this spectacular, unsettling event. Polaris, the North Star, has been our celestial anchor for millennia. Its unique position almost perfectly aligns with Earth's axis, making it appear fixed in the northern sky while other stars wheel around it. For ancient sailors and explorers, Polaris was a lifeline, a cosmic compass pointing north. Even escaping slaves on the Underground Railroad followed the drinking gourd to Polaris, seeking freedom. But Polaris is more than a single star. It's a complex system, with a supergiant primary and two smaller companions locked in a gravitational dance. Its stability made it a symbol of constancy and hope, a dependable guide in a changing world. The idea that this symbol could suddenly explode is a jarring reminder: the universe is dynamic, not static. The loss of Polaris isn't just astronomical, it's cultural, altering a sky humans have trusted for generations. Now the map of our heavens has changed forever. We're left to navigate a world without our most reliable star. Why do we study stars? What draws us to gaze upward night after night, searching the sky for distant points of light? Curiosity drives us to understand where we come from, and what the universe is made of. The stars have always sparked our imagination, inspiring myths, art, and science across cultures and generations. Stars are cosmic forges, creating the elements that make up our world and our bodies. Every atom of calcium in our bones, every bit of iron in our blood, was born in the heart of a star. By studying them, we test the laws of physics in extreme environments, learning about gravity, fusion, and the forces that shape everything. These discoveries push the boundaries of human knowledge and technology. Looking at stars is like looking back in time. The light from Polaris took 323 years to reach us, so its explosion actually happened in 1702. Every star is a message from the distant past, telling us the story of the cosmos. This cosmic time travel lets us piece together the universe's history, from galaxy formation to stellar evolution. We see how everything changes, evolves, and sometimes disappears. Studying the stars gives us perspective, reminding us of our place in a vast, ever-changing cosmos. It shows us how small we are, yet how connected we are to everything out there. It humbles us, inspires us, and connects us in a shared quest for knowledge. The wonder we feel is universal, crossing boundaries of age, language, and culture. The loss of Polaris is a stark reminder of the universe's unpredictability. Even the brightest stars can vanish, changing the sky forever. But it also renews our sense of wonder and our drive to explore. Each discovery leads to new questions, and every answer opens new mysteries. That's why we look up. We seek meaning, connection, and inspiration in the stars, reminders that the universe is vast, mysterious, and full of possibilities. What does it really mean for a star to explode? It's not just a simple burst, it's one of the most dramatic and powerful events in the universe. For massive stars like Polaris, this explosive end is called a supernova, the universe's most spectacular and awe-inspiring finale. A cosmic event that can reshape entire galaxies. Unlike our sun, which will quietly fade away as a white dwarf over billions of years, massive stars burn through their fuel much faster and die young, fusing elements in their cores all the way up to iron. When fusion finally stops, gravity takes over. The core collapses in on itself, and a powerful shockwave rips the star apart in a cataclysmic blast that sends material hurtling across space. For a brief, dazzling moment, a supernova can outshine an entire galaxy, releasing more energy in a few weeks than our sun will emit in its entire lifetime. This is exactly what we're witnessing with Polaris, a core collapse supernova, marking the violent and spectacular end of a massive star's life. But supernovae don't just destroy, they also create. In their explosive deaths, they give birth to new possibilities. the explosion forges elements heavier than iron, like gold, silver, and platinum, and blasts them out into the cosmos, enriching the universe with the building blocks for new worlds. This cosmic debris drifts through space, eventually coming together to seed new stars and planets, fueling the universe's endless cycle of destruction and creation. The gold in your jewelry, the silver in your electronics, all of it was born in the heart of ancient supernovae, forged in the fires of dying stars. Polaris's death is the universe's ultimate recycling program, turning endings into new beginnings on a cosmic scale. Its end marks the beginning of new worlds, new stars, and perhaps even new life somewhere in the universe. Even in destruction, the cosmos creates, reminding us that every ending is also a new beginning in the grand story of the universe. How do we know what happened to Polaris? We're cosmic detectives, using light as our primary clue. Telescopes collect starlight and break it down with spectroscopy, revealing a star's composition, temperature, and motion, its unique fingerprint. Scientists build models of stellar life and death, then compare real data, light curves, spectra, to these simulations. The global response to Polaris's explosion is massive. Telescopes on Earth and in space, from Hubble to James Webb, are gathering data across the spectrum. Each wavelength, radio, X-ray, gamma, offers a different piece of the puzzle. Science thrives on collaboration and self-correction. We test ideas, revise theories, and build a clearer picture of the universe. The Polaris supernova is a tragedy for a beloved star, but a rare scientific opportunity. We're witnessing a cosmic event up close, testing our understanding of stellar death. Every observation brings us closer to unraveling the mysteries of the stars. The universe is our laboratory and Polaris is our latest experiment. A supernova like Polaris's sends ripples across the cosmos, a grand spectacle of celestial fireworks that echoes through the vastness of space. First comes the brilliant blast of light, photons that have traveled an incredible 323 years to reach us, each one a messenger from the past, telling the story of the star's final dramatic moments. Neutrinos, those elusive, nearly massless particles, escape the core at nearly the speed of light, carrying direct information from the heart of the explosion, a whisper from the star's core. Then comes the debris, a vast, expanding cloud of gas and dust, the supernova remnant sweeping majestically through space for thousands of years, a cosmic wave reshaping the universe. This powerful shockwave can trigger the birth of new stars and planets, making the death of one star the catalyst for new creation, a cycle of death and rebirth in the cosmos. What about Earth? At 323 light-years away, Polaris poses no threat, no extinction-level event, just a cosmic spectacle for us to marvel at from our distant vantage point. The real impact is cultural and scientific. The sky will look different, with a brilliant guest star shining for weeks, a temporary beacon before fading into the darkness. The North Star is gone, and future generations will navigate by other means, adapting to a sky without its guiding light. It's a fundamental change to our night sky, a map redrawn after millennia, altering the constellations that have guided humanity for ages. The universe reminds us, nothing is permanent, everything is in a state of flux, constantly evolving. Even the most steadfast stars can vanish, leaving behind only memories and the stories we tell. We are witnesses to cosmic change, observers of the universe's grand narrative, unfolding before our eyes. The global scientific community is electrified. This is the astronomical event of a lifetime. Supernovae in our galaxy are rare, and to witness one from a star as iconic as Polaris is unprecedented. Astronomers everywhere are racing to capture every possible detail before the supernova fades. The window is short, the brightest phase lasts only weeks. We're searching for clues, the elements in the explosion, the fate of Polaris's core. Will it become a neutron star or a black hole? We'll watch for signals from a newborn pulsar or the gravitational effects of a new black hole on Polaris's companions. The real excitement? This event could challenge our theories of stellar evolution. If Polaris's explosion defies expectations, we'll have to rethink what we know about how stars live and die. In science, surprises are opportunities to learn. The universe is full of surprises, and Polaris's story is no exception. Polaris hasn't always been the North Star. Earth's axis wobbles, so different stars take the role over millennia. In ancient Egypt, Thuban was the North Star. In 12,000 years, it'll be Vega. Supernovae are mind-bogglingly powerful. One can release more energy in seconds than our sun will in 10 billion years. The Crab Nebula, a supernova remnant seen in 1054, still glows today, with a pulsar spinning at its heart. Polaris's explosion will create a new nebula, a monument to a lost star studied for centuries to come. Polaris was a triple-star system. Its companions will now orbit in a changed gravitational landscape. Astronomers will watch these survivors closely, learning about the mass lost in the explosion. The cosmos is always evolving, and every event teaches us something new. Even in loss, the universe offers wonder. The explosion of Polaris is a powerful reminder the universe is dynamic, unpredictable, and endlessly fascinating. Its loss is poignant, but it's also a rare opportunity, a front-row seat to cosmic transformation. Our ability to detect and understand this event is the result of centuries of scientific progress. Now, we'll analyze the supernova's fading light, search for the remnant, and watch Polaris's companions adjust to their new reality. Each discovery adds to our cosmic storybook. This isn't the end of Polaris's story, it's the start of a new chapter, inspiring future generations to look up and wonder. The night sky is a living masterpiece, its stars telling stories across time and space. Our job is to learn how to read that story, to keep asking questions, and to keep exploring. The journey is far from over. With every cosmic surprise, it feels like it's just beginning. So keep looking up. The universe always has more to show us.